So, hello, student. Do you ever think do you observe that your friends get easily infected in infection, and and others of your friends not get easily infection? What do you think? What may be the reason behind that? Or now, do you know why we are all in our house now? Why your schools are closed? Because the answer will be the coronavirus, na? So for that, what may be the way to prevent, get rid of from this disease? Maybe the vaccines, right? So let's today talk about the immunity and vaccination, right? So first of all, what is immunity? Immunity actually protect us from infectious agent. So immunity is the ability of an organism to resist a particular infection with the help of some defense mechanism. In our body, we have two types of immune systems are there: innate immune system and acquired immune system. Innate immune system is inborn type of immune system. What is innate immune system? Innate immune systems are inborn type of immune system, always present with us. By birth, we'll get that immune system like our mucus, saliva, tears, all contain some. This is a part of our innate immune system contains some antibodies, specific type of that protect us from infection. But now, acquired immune system is developed after infection, and it's a more advanced type of immune system, and it's a more specific type of immune system than innate immune system, right? So, next we'll talk about now that what is the different ways that these two types like concept of immunity, like immunity have adaptive immunity and innate immunity. Adaptive immunity may be natural, may be artificial. Natural means it's like it may be passive or active type of infection. A passive may be like with directly involvement of antibody, and naturally suppose some infection occurs, antibody develop in our body. In artificial type of adaptive, like antibody transfer and active immunization. Now vaccination belongs to the artificial type of active immunity, right? So vaccination is belongs to artificial type of active immunity. Now we'll see what is actually vaccination or vaccine, right? So actually the vaccines is an antigenic preparation used to stimulate active immunity to create an immunological memory to prevent effect of infection, right? So in so that we do not get infection, so that's why we are producing antibody before infection, and that's why we all take vaccination, right? So vaccination first introduced by the Edward Jenner in 1798, and it came from Jenner first observed that those are dairy workers, they are prevented from smallpox. Smallpox, there is two type of poxes there. One is cowpox, another is the smallpox. Cowpox is less severe type, smallpox is more advanced type and deadly. That's but he Jenner observed that those dairy workers have a cowpox. Those dairy workers have cowpox. That's a mild form of pox. That's they are immune to immune to smallpox. From that observation, he developed the concept that if we inactivate or any pathogen in mild condition in our body, they develop antibody to protect our protect from small us from other infections or smallpox, right? So next is that we'll see. that how Edward Jenner, the discovery of Edward Jenner. Now, Edward Jenner, this is a historical root. Discipline of immunology has its root in the early vaccination trial of Edward Jenner. This is Edward Jenner, right? So, early vaccination route. Now, next we will see the different, what's are the types of vaccination now we have available. You all undergo vaccination, right? So different ways that we can develop vaccines. Vaccines actually we can produce either inactivate the pathogen. So there are several ways to develop vaccines to increase our artificial active immunity. Like in live attenuated vaccines. Live attenuated means you inactivate the pathogen but the pathogen attenuated means the is pathogen is live but it is not able to cause. Attenuated means attenuated means that the pathogen not able to cause disease. So it will not able to cause disease. So that's why attenuated form. So attenuated types of vaccine, like we can see that the measles, mumps, polio vaccines, measles, mumps, polio vaccines are two types: oral polio vaccines and the Sabin vaccine and the Salk vaccine, right? Rubella, tuberculosis, varicella, yellow fever, all are live attenuated type of vaccines. Inactive or killed vaccines or inactivate forms of vaccine where we develop we use as an inactive pathogen to develop immunity against, like examples like those are cholera disease, influenza, hepatitis A, polio, or as a Salk type of vaccines. These are inactive or kill vaccine. Toxoid, like here we use toxins of the pathogen. Pathogen release some toxins. So in that toxin actually cause the disease, right? We use the inactive form of toxin to the develop our immunity against, like in case of diphtheria, pertussis, and tetanus, as an example of toxoid type of vaccines. Like in case of when any pathogen enters in our body have macrophage. Macrophage actually we have macrophage, and macrophage actually catch up the pathogen or phagocytose the pathogen and forms the APC or antigen presenting cells. Antigen presenting cells, APC or antigen presenting cells. Antigen presenting cells actually they display the pathogen and so that the other immune cells can recognize it, and then it will activate the T helper cells, T helper cells and T helper cells, TH cells, helper cells and TH cells. Those convert TH cells activate the B cells. B cells or B lymphocyte, and B cells convert. B cells are two type: one plasma B cells and memory B cells. It's converted into plasma B cells and memory B cells. This memory B cells, one type is produced plasma B cells, another produce memory B cell, memory. B cell. So, so plasma B cell and memory B cell. Plasma B cell produce antibody, and memory B cells that's actually keep, keep up the memory response for the infection, and it will the basis for our vaccination, that is memory development of the infection, so that the our immune system able to attack if any in this type of pathogen came during our lifetime, right? So hepatitis inactive subunit vaccines are inactive exotoxin like hepatitis B vaccines. Other type of vaccines like in DNA vaccines is available where we use as DNA recombinant DNA technology to develop vaccines, right? Now, next is that examples of different types of vaccines. So examples are like different vaccines which are working right now. Name BCG is Bacillus calmette-guerin. It's used for tuberculosis disease against tuberculosis disease as a first dose as soon as possible after birth. Polio vaccines against polio disease, DPT vaccines 6 weeks minimum, typhoid vaccines after 6 months, measles vaccines 2 years, um, minimum. This is a minimum age of dose. Mumps vaccines, rubella vaccines, tetanus vaccine, and hepatitis vaccine. So these all type of vaccines are available out now, so that's actually prevent us from infectious infectious agents, right? In that way vaccines work, right? So thank you.